So, okay, I'm going to talk to you about a bit on how to use in the best way your Open Package Manager today. I'm giving the presentation, but of course all this work has been the result of a team effort of many people that you can see listed there. What I'm going to talk about is just an aspect of the work we are doing on Open Material today. Actually, it is an outcome of a long research history. Many people in our team have been working on package management issues, both theory and practice, for almost 10 years. So you have 2 European projects, one which was EDOS, the second which is Mancusi. We ended up getting a lot of nice theoretical results, a few efficient and stable libraries already in OCaml. And what is really interesting, we also managed to bridge a bit some research communities, getting people from operational research developing efficient solver for dependency solving that we can reuse today. Well, some of these tools has been reused as a foundation of the Open Package Manager, which is actually at the beginning was called OCPGet on the Pavilion office next to mine. These 2 libraries are IPSUDF and those that you can find, it's kind of a recursive presentation here, that you can find inside Open, and you can install using Open if you want. There is some relevant literature for this talk, but we'll not go over all this. But let me just take a step back and give you some background about Package Manager. We have already heard about Package Manager today. What's a Package Manager actually? Well, if you look at Wikipedia, they tell you, well, it's a set of tools that are used to automate a set of tasks which are usually boring, you don't want to do. So installing, upgrading, do configuration, removing packages of this, that's fine. The tricky part is doing this in a consistent manner, which is written there. That's where it gets difficult. And of course, when you do this, you end up managing something like software packaging versions, dependencies, and all this stuff. How many package managers are around? Well, I didn't count them. I wouldn't be surprised to see more than 100 of them around. Less than programming languages, but quite a bit too. So you have package managers for binary distribution, like for Linux, APT, APT2, YAML, etc. If you are a BSD guy, you prefer a source-based package manager, like BSD, Portage, or whatever. Probably Open could be fit there, source distribution package manager. Then you have language-specific package managers. Open could be thought as a language-specific package manager also for OCaml, but it is more general than that. Then you have application-specific package manager. Steam, after all, you use it just to play your games, but it's a package manager. And then you have decentralized tools like Zero Install, we have heard about earlier. You have very, very interesting approaches like the functional approach by DINSOS, etc. Many of them are around. Well, what's inside the package management system? Okay, what kind of tools do you have? Well, usually you have 2 sides of the story. You have people maintaining the packages and providing for you the packages you are going to install on your machine. Let's call this the server side or repository side. And so there, the challenge is to maintain a coherent set of packages that you offer to your clients. Make sure they are coherent, means spotting errors, spotting mistakes, spotting incompatibilities, and in particular spotting packages which are in the repository which can never be installed. So there is no point in having them there, okay? On the client side, things are tricky also, because of course you have to fetch sources or binaries, eventually compile, authenticate the sources if you care about security, probably solving dependencies. So if I need to install package B, the dependency and D, and then, well, I need to go through all this and sort it out. If there are several possible ways of installing a package, you need to enforce some kind of policy. We are going to talk about this today. Then you need to deploy the solution. All this is pretty complicated. But, well, here we focus just on two aspects of, which are really common to all these package managers around, because they differ a lot. But dependency solving, having policy is something you find everywhere. But dependency solving, how hard is it? Okay, well, actually, I forgot to put a pause here, so you already have the answer to that. But for a very, very long time, we have been using package manager, and we didn't even know about the complexity of the issue at stake. Well, You have to wait until 2006 when we decided to look at it from a theoretical point of view. And it's not very difficult to see that for most of the package manager you can find around the metadata that you use can be encoded as a Boolean satisfiability problem, and vice versa. So it is really an NP complete problem, finding an answer to the question, is it possible to install an OCaml package on an empty machine, for example? Then if you really want to play some funny games, you can try to use another proof of NP hardness by encoding Sudokus as package management. This can be done. And actually, if you really want, you can use your package manager to play Sudokus if you don't know what to do in your weekend, for example. So one application that came out immediately out of this remark, NP completeness, was that, well, fine. So now I have a standard way, a uniform way of finding non-installable packages in a repository. Pretty easy. Just convert your installability problem into some Boolean formula, call a SAT solver on it. Well, actually call the SAT solver on every single package that you have in the repository. When you have tens of thousands of packages in the repository, that means calling tens of thousands of times the SAT solver. That might take a long time, right? So we were scared. But the good news is that it's feasible in practice. Practical instances of metadata for packages today are very easy to handle for modern SAT solvers. You need to have at least something equivalent to Minisat. And actually there is one which is included in the DOS library written by Jerome Williams back in 2006, which is specialized for this task and then can check the installability of tens of thousands of packages in just a few seconds, which is really impressive. This technology has been used in the Debian community since 2006. So you see this fantastic, nice website here, qa.debian.org/DOS. It's just a wrapper around one of our tools, which is DOS-check, and tells you, for example, that it is not necessarily a good idea to try to install a Debian unstable distribution on ARM or Word today, because there are hundreds of broken, non-installable packages there. And this is actually used in quality assurance. All these diffs here, I will not spend time on this now, are just comparing the situation today with yesterday and the day before and see if things are improving or getting worse. And it is actually used to improve the quality of distribution. Well, since mid-2014, this same technology is now available also for us, for people using Open. If you go to ows.ireal.org, this is just a variant of DOS-check. This is the Open Weather Service that tells you for each of the available stable releases of the compiler from 3.12.1 to 4.2, for each version, for all the packages which are packaged in Open today, whether they are installable or not, just looking at the dependency issues. You would expect that everything should be green. No, there are a lot of red places, so just go around there, click on the button, you will see the answers. The point is that indeed these kind of tools are fantastic and priceless if we have a proper quality assurance process which is in place. Well, OPAM is a young system, the platform is a very young system. Unfortunately, at least from my point of view, we have no such QA process in place, and we need to copy intelligent ideas from other people, like Debian people who did this for more than 15 years, ready to help anybody who is willing to do this. But that wasn't the core of the problem. It is just to remind you that dependency solving is hard in general. But what is worse is that when you want to install a package on your machine, it is not just a matter of checking whether a package is installable. It is also a matter of knowing how are you going to install the package on your machine. Because how many ways can there be to install a package on your machine? Let me give a simple example. So imagine on your machine you have a certain number of packages, Q1 to Qn, which are present there, installed in version 1, okay, but available also in version 1 and 2. Then you ask your system to install a component P in version 1. That depends on all of the queues, but you don't specify any version constraint in there. Well, any of the 2 to the n configuration, which are all the possible variants of having Q in version 1 or 2 for ODIs, are actually a solution. Okay, so if you call a solver, he will just pick one. But which one do you choose? Should we choose a paranoid version? I mean, just install P, don't touch anything, leave all the other queues as they are. Install P and upgrade all of the queues, or maybe upgrade all of the queues only if their source package is named OCaml P4 or whatever. No, which one? I know, we need a way to handle this. If you look at what is done in current package manager, which are mostly developed using old approaches, people essentially try to avoid the problem in different ways. I mean, you have something like the centralized and group approach, that is to say, you, the user, do nothing, I do everything for you. There is a patch Tuesday where I upgrade everything for you. You just download this particular patch and everything will be fine. You can try to avoid dependency, like what is done in the App Store. You can try to make coexist many different versions of the system as you want. That's an approach you find in Coexist, for example. But if you try to handle the problem directly, you face it. Most of the package managers around use a standard strategy, which is just code a particular ad hoc strategy and algorithm that, for example, identifies some suites of components, and then when you try to install something, it finds a solution that tries to stick to this particular order, which is not necessarily a good idea. Just to give you the point is that when things go wrong using this particular ad hoc strategy you don't know, you can really get lost. Let me present a simple example of what actually happened to me many years ago, and that motivated partly one of the effort we did in this kind of research. Well, many years ago I had to install some particular package in Debian which was called the helper, which is just a tiny package containing a few Python scripts. Well, the standard package manager starts reading the packages and then after a while say, okay, you want the helper, no problem. I will bring you also all these extra packages which are, you know nothing about, but I find it nice to bring them in to satisfy your particular dependency. Well, these are extra packages. Disk space is particularly cheap, so who cares? Okay, I get it. Then there is a second part where it says, actually, if you really want the helper, I'm also going to remove a lot of stuff here, so I will not go through everything here, but in particular you see there is one touch package here I do not want to see removed. So luckily, before doing anything on my system, actually this package manager, as many sensible package managers, just ask for confirmation. So you wanted one package, I'm going to upgrade 75, install 80 new, remove 42, etc. Are you sure? I don't know. What should I do? Well, usually abort, stop. Okay, stop there. Okay. So the point is that here there is a fixed strategy that sometimes doesn't do what I want, and I have no idea of how to handle the situation. So let's go to the proper way of doing things. What we believe, you should build modular package managers, separating concerns between them. And so you know that dependency solving is an NP-hard problem. Dependency solving with optimization, which is basically what you want when you install on your machine, is even harder. So please just stop coding a petty solver every time you want, just because you want to code it in Python, on Haskell, or in OCaml, in whatever language you prefer. It's a complex thing. Just use something else, adopt a modular approach. This means find the step number one, use a common description format for your upgrade issues. And so let's encode the Debian installation problem, RPM installation problem, Eclipse problem, Open problems, or whatever package installation problem in this common format. And I use this as a pivot format to call many other different solving technologies which are available out there. Maybe you can like encoding this in a SAT solver, but maybe the most efficient way is using an integer linear programming approach or an answer set programming approach. You don't know, it's not our business, we are just language guys. Okay? And on the other side, you need to provide a means for expressing our choice. So we need a full-fledged preferences language that allows us to say to the solver what kind of solution we really want. So just to give you an idea of what this CUDF file looks like, it's very reasonable, it is human readable, it is extensible. This is actually extracted from the CUDF file which is generated by OCaml every time you want to install something. For example, install XML, all packages are represented this standard way. And then what about user preferences, which is something not everybody knows yet? Well, a preference expression is something I'm using to tell the solver what I want. So preference expression have essentially 4 components. The first component, which is a package selector, so just allows me to specify a set of packages that I want to operate on. They have measurements that can be applied to package selectors to obtain an integer value that I can use in an optimization. Then I can maximize or minimize the value of this particular measurement, and then I can combine different measurements today actually in the lexicographical order. Let's see some of these examples. So as package selector, you have a variable today, you can use it in OCaml directly. A package selector which is called solution. Solution is just the set of packages that will be installed after you run the package manager. Down and up are the set of packages which are downgraded or upgraded under this operation. Remove the new, I mean this is intuitive, just the package which are getting removed or new package I didn't ask for. The number of packages that get changed, so their version changes. The packages which are explicitly mentioned in the user request, this is request as a selector, or maybe mentioned in the user request for installation or in the user request for upgrade. And these are selectors. And on top of them, you can apply measures, which are, for example, count. I mean, how many packages are in the final solution. You can sum the values of integer fields of the metadata of the packages, like, for example, compute the sum of the installed size of all packages in the selector X. I mean, change it, remove it, install, whatever. Count the number of packages which are not at their latest version, and many other things that are more complicated. I will not enter into detail them here. Then you can optimize. I mean, optimize means you can add a plus or a minus to say to the solver you want to maximize or minimize this particular value. So find me a solution that maximizes or minimizes this particular value. And you can also combine them in this way. Like, for example, this particular preference here is telling the solver, look, I want you to install the packages I mentioned on the command line, but find me a solution where you minimize the number of packages that get removed by what you are going to do. And after that, try to make as little changes as possible to my system. This is what I wanted to have when I had this deadback problem that I didn't have. You just get stuck. But if you want to use all this, it's very funny. Once you have a preference language, you start to play with it. For example, when you want to install your packages, you can take a paranoid approach, like the first preference there that is don't remove anything and change as little as possible. This would correspond to the fact of just-in-time UP in the example I gave before and not touching the queues. Or I can be in a trendy approach that is, please bring in everything which is new, so don't remove anything, but then give me a solution where everything is as up-to-date as possible. Okay. I'm sure that if I run a poll in this room, I will have a lot of people liking the first and another lot of people liking the second preference. It is just a matter of your personal need in that particular moment. Huh? Because of course, this trendy approach there may need you to upgrade all of your packages when you wanted to change just a few ones you're working on, for example. So it depends on what you want. You can try to refine them. For example, you can have a local focus. Here with a paranoid approach would be, okay, don't remove anything and then bring to the latest version just the packages I mentioned on the request. And once you do it, also take care of minimizing the number of downgrades and the number of changes, for example. But if you do this, the only package which will be at the latest version of the package you only mention on the command line, not necessarily their dependencies. So maybe this is what you want, maybe what you want to update also the dependencies. So you can also start refining the preferences you use in this way, like for example, update all the packages which I mentioned, and if you need to change something in my system for satisfying the request, also make sure you have the latest version of the modified packaging to top everything, for example. But this was also other drawbacks. So the bottom line here is that there is no one-size-fits-all solution. Okay? We can use a default in the system. There is a default in the system, but it is not necessarily what you want. It depends on who you are, what you want to do. Okay? And the flexibility of the preference language allows you to specify what you want. Some more exotic example, let me skip a race because I'm running out of time. You can do some strange things, like for example, what is the minimal system size I can build using my components? Here you can minimize the installed size of all the packaging in the solution and minimize the number of packages in your solution. So you want to install just core HTTP. What is the smallest number of things installed which are needed? Or you can say, I want to install everything that can be installed together. So a sort of Noah's Ark here, so maximize the number of packages in the solution, if you want to do it. Or maximize, find a solution which is up to date, as up to date as possible, and contain the largest set of packages available. Or you can, if you have a tag in your metadata that allows you to know what is the compile time for a package, you can also say something like a fast bootstrap option, which is minimize the time to compile all the packages which are in the final solution to get my particular thing installed. I mean, you can play all these kind of games also. You can even repair a broken system configuration. Imagine you have a package installed on your machine, and at some points, the metadata, like happens very often today because people go and feed with the open metadata without changing the version of the packages, as you know. So it can be that after an update, you discover your current configuration is broken because the metadata changes and what is installed can no longer be consistently installed together. How do you fix it? Pretty easy. You just say, you issue an empty request, you don't ask for anything, so nothing is fixed. You just use one preference, which is change as little as possible the system, but get me a solution. Okay, I want a set of packages which are consistent together, and as little different as possible from my current configuration, which is broken. And then you can play games like, okay, fix it, but don't downgrade or anything or something like this. And did you notice? All of these funny tasks can be performed with 0 changes to the package manager code. It is just a matter of using in a smart way your preference language. It is extremely flexible, extremely powerful. So I'm going to conclude very soon. So there are many available external solvers today. You can pick a few of them. You can use all this ICFP for managing your packages. It is supported in Open, in particular once solver GSPQ is supported out of the box since version 1.0, and in the current version, when you type open -help, you discover there is a way of specifying your criteria. I mean, what I have shown to you is actually usable directly in Open. You can choose a particular external solver, the default ESPQ, if installed with you. If you have some strange or situation, you can ask the system to dump CUDF files that you can pass it to developer teams and test or examine. So the only issue which was left open for a while was getting your external solver on your machine. So if you're a Debian or Ubuntu user, it's pretty easy. Just apt-get install ESPQ, it's running on your machine, but you need the latest one, 1.9 something. Okay? If you don't find a recent ESPQ on your machine, which is annoying, you have just use zero-install, for example. If there is a binary array will be installed. If there is not a binary array installed because there are issues with the C library or whatever, etc., well, I also provided the Dockerized version, which is pretty easy to use. So just get this Docker file up there. And if you are running a system, Open like Open, on low power architecture where you do not want to run a SAT solver or an optimizer on top of them, just use a solver farm which is available here. Big thanks to many people in Open who did it. You can help another guy asking for feature. Just try out the different preferences. Let's find some nice, useful profile. Let's give them a name so you do not have to write this long expression. Test the expressivity of the preferences languages. Maybe you want to do something you cannot do, but with an extra combinator could be done. Let me know. And help us debug the Open configuration by sending you CDF file whenever it is necessary. So to conclude, so I'm not too much over time, basic message, package management is a complex task, very hard, and particularly a very hard part is dependency sorting and optimization. So Let's share about modern package manager these two parts, so in particular dependency solvers and user preference languages. So now you can already use all this in Open today. You should use external solver and Cleversive today. You might even, if you want, tell some jealous people in other programming communities, we have something they don't have, but they could have it because it's very easy to import in their technology. You can learn more about all this, and I stop here, and I'm ready for any questions. Thanks a lot.
Time for a couple of questions, maybe?
Does the solver distinguish between the package which were installed because I asked it to install it something in the past and the packages which were installed because of the dependency?
Actually, this information must be maintained by the package manager. It is already the case today. So in Open, you have an information about what are called root packages, and the package you asked explicitly for. And these are handled in a particular way when you call the external solver by specifying that you, for example, you don't want to see them removed. You want to see them still available. Then what you want to do with these packages, should they be at the latest version, pin in a particular version, etc. This is outside the scope of the solver. It is what you want to do through the higher level of the package manager. But it is already part of Open today.
I'm sure you went at some point to the people that work on the package manager of other Linux distributions, for example, trying to sell them your technology. So why don't we have CUDF in Lyon, in Fedora, for example? What was the excuse?
Wait a second. So a complex question, simple answer. I don't know. If you look at Debian, for example, if you're a Debian user, this technology is already incorporated in there. So you have a switch which is called ---- solver. You can use on apt-get. You can use an external solver, and then it goes through exactly the same technology you have seen here. Now, why they didn't adopt it, because a part of this is written OCaml and they want it to be written in C++ or Python, I don't know. I mean, this is just a troll, okay? Then what about Red Hat or what about other distribution? We did try to contact them. We never managed to put our hands on the people who are really responsible in package management. Don't forget that there is also a big resilience in the community. If you already have a tool, you are resilient to change it. So it was much more fantastic to import this technology directly in Open, since we were starting from scratch. And luckily we imported this technology because, since you see, we are keeping all versions of packages in the Open repository today without external solver. It is simply not possible to handle this properly. But if you have contact with other people interested in with this, please tell them, and we are very open, very ready to collaborate.
And that profiles that you have shown, Paranoid and Tame, they are available now, or you're searching the best set of criteria to set them?
Actually, Paranoid and Trendy were keywords used in the first competition of solver we ran something like 4 years ago. And actually, they are even recognized as shorthand. Paranoid and Trendy, you can use them. But they are just example of what you can specify, and we are really looking for profiles that correspond to particular usages which are interesting. You can really have many combinators today, so the point would be to find something like a dozen different profiles that can be used. Let's fix them, put them in the preferences configuration file, and use these keywords instead of long combinator expression. You lose nothing, of course, because you can still use a full expression language, but it will be much cheaper to have a shorthand with something which is very well understood, instead of thinking about what exactly this optimization function will do on my system.
And by the way, asking about these shorthands, I think before 1.2, apparently there was, I read somewhere that you should specify something like minus changed, comma minus removed. It is supported, or it is
That was the older preference language. It is still supported. So minus changed is a shorthand, minus count of changed. You can still use it. It's still supported. It's backward compatible, luckily.
Okay.
Thank you for that.
Okay.